what if you could reach into any photo you've ever taken and just pull an object right out? I know, it sounds like science fiction, right? But today, we're going to break down an AI that can pretty much do just that. This is SAM 3D. Okay, so take a look at this. To you and me, it's obviously a chair. It has depth, it takes up space, it's sitting in a messy room. But to a computer, this is just a flat grid of colored dots. It has zero built-in understanding of the shape, the shadows, or the parts of the chair it can't see. Our brains do that part instantly.
But what if? What if an AI could finally see it the way we do? Understand its real shape, its texture, where it is in the room, and then let you just lift it, pull it right out of the screen as a perfect 3D model. Well, that is the incredible breakthrough behind SAM 3D. Now, to really get why this is such a mind-blowing achievement, we first have to understand a huge challenge that has stumped AI researchers for decades. Let's call it the flat photo problem.
I mean, think about it, right? Traditionally, if you wanted a 3D model, you needed a whole photo shoot from every single angle, or maybe one of those fancy, expensive LiDAR scanners. And yet, our brains can just glance at one photo and figure out the object's shape from clues like lighting and shadows. That gap between us and AI has been absolutely massive.
So why has it been so hard? Well, it all boils down to one giant roadblock, the 3D data barrier. See, to train a powerful AI, you need data, a ton of data. But in this case, you need something that barely exists, a massive library of real-world photos that are perfectly matched up with super high-quality 3D models. That data bottleneck has been a total showstopper for the entire field.
But now, a new model has found a seriously clever way to just smash right through that barrier. So let's meet the hero of our story, SAM 3D.
SAM 3D is a generative model, but it's not just spitting out a vague blob. Nope, it reconstructs the whole shebang. The three things you absolutely need for a real 3D asset. First, there's the geometry. That's the actual shape. Then the texture, what the surface looks like. And finally, the layout, its exact position and rotation in 3D space.
And this is its superpower. See, a lot of other models, they do okay with a nice, clean image of an object on a plain background. But the second you throw them into the chaos of a real-world photo, they just fall apart. SAM 3D, on the other hand, actually thrives in that mess. It can figure out an object's shape, even when it's partially hidden behind something else.
So the big question is, how did they do it? How did they crack that data problem and give it this amazing ability? Well, the answer is in this brilliant multi-stage training process. Let's break it down. The researchers themselves say they basically adapted the playbook from all the biggest hits in AI right now, like large language models and robotics. So this isn't just about building a bigger model, it's about coming up with a much smarter way to teach it. Okay, so the whole process uses this great analogy. Stage 1 is pre-training. Think of this as textbook learning. The model studies millions of perfect, clean, synthetic 3D objects to just learn a basic vocabulary of shapes. Next up is mid-training, which is like a supervised internship. Here, it starts to learn about real-world complexity by seeing those perfect synthetic objects digitally pasted into messy, real photos. And finally, there's post-training. This is its on-the-job experience, where it gets fine-tuned on real pictures to make sure its final results actually look realistic to a human eye.
And that last stage, that's where the real genius is. Instead of asking 3D artists to build models from scratch, which takes forever, they just have the AI generate a few different options. Then they simply ask a person, hey, which one of these looks best? That choice gets fed back into the model to make it smarter. It's this awesome feedback loop, a virtuous cycle that lets them get tons of high-quality data at a massive scale. It's brilliant.
All right, so the training method is super clever. But the real question is, does it, actually work? Let's get to the results, because they are seriously impressive.
Get ready for this. When they put SAM 3D's creations head-to-head against the previous best model and asked real people to pick their favorite, people preferred SAM 3D's results 5-1. Let me say that again, 5-1. That's not a small improvement, that is a total blowout.
And it gets even better. When they did the same test but for entire scenes, with multiple objects all interacting, that number jumped to 6-1. This tells you the model isn't just good at single objects, it actually gets how things are supposed to fit together in a real 3D space.
The hard numbers tell the exact same story. So look at this chart. The chamfer score basically measures how wrong the final shape is. Lower is better. And as you can see, SAM3D's score is less than half of its rivals. Then you have the IOU score, which measures how well the 3D volumes overlap. For that, higher is better. And yep, SAM3D is crushing it there too. On every important metric, it's just in a whole different league.
So what does all this mean? Well, this is way more than just a cool academic paper. This kind of breakthrough has massive implications for how we're all going to interact with the digital and physical worlds.
I mean, just imagine a robot in a warehouse that can actually see and understand the 3D shape of any object it needs to pick up. Or think about AR glasses that can place a digital couch in your living room that looks so real you'd actually try to sit on it. For gaming and movies, this is a total game changer. Creators could just scan real-world items and turn them into digital assets in seconds.
And that's really why this matters so much. SAM3D isn't just a tool for one specific thing. It's a foundational capability. It's a building block that future innovators are going to use to create apps and experiences we can't even imagine yet.
So let's zoom out for a second. What does a model like SAM3D really mean for the future of artificial intelligence? Ultimately, what this is all about is perception. This is a huge step toward an AI that doesn't just recognize patterns in pixels, but one that actually perceives the world with a genuine, human-like understanding of three-dimensional space. So I'll leave you with this thought. If you could instantly turn any object in your world into a 3D model, what would you pick first? It's pretty amazing to think about how this blurs the line between the physical and the digital, and we're really just at the beginning. If you want to dive deeper, the link to the full paper is in the description. Thanks for joining us for this explainer.